Welcome to the class of engineering mechanics. Today we will discuss about moment of inertia. Now, what is moment of inertia? We have to learn what is moment of inertia. The definition of moment of inertia is the product of the force and perpendicular distance between the point and the line of this action force is called moment of inertia, right? So for moment of inertia for a plane section or the plane area, how we can calculate, or what is the representative figure of this moment of inertia is, now let's consider. At first let me write moment of inertia of a plane area. Okay, now take a plane area. Okay, consider a plane area whose moment of inertia is required to be find out, and similar for in case of CG in the last class, for a irregular shape, a plane area, we divided the figure into various part, into various areas. Okay, small areas like A1, A2, A3 up to nth term. So in this case also we split up the whole area into a number of small elements. So we have to discretize the total area into small elements. So let's assume A1, A2, A3 dot 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 up to nth terms is our area of small elements. Okay, and R1, R2, R3 up to Rn term is equal to corresponding distance of the elements from the line about which the moment of inertia is required to be find out. So we can say this is corresponding distances of the elements from the line about which the moment of inertia is required to find out. Okay, now moment of inertia of the area will be, if we represent moment of inertia as I, so we can write as I is equal to A1 R1 square plus A2 R2 square plus A3 R3 square plus up to nth term, that means An Rn square. Okay, so we can say the summation of this area into R square. So this is the numerical representation of moment of inertia of a plane area section. Okay, so next question comes in our mind: what is the unit of moment of inertia? From this equation we can clearly say that in case of SI unit, the moment of inertia will be meter to the power 4. How? This is area unit is meter square into, this is R, this is nothing but a distance, so meter square, so meter square into meter square is meter to the power 4. So in case of SI unit we can say that this is meter to the power 4, and CGS centimeter to the power 4, millimeter to the power 4, we can say it. Okay, now how we calculate the moment of inertia of any body? So there are some methods. Okay, so there are normally two methods are there. Number one is Raoult's method. So let's start with methods for moment of inertia. So there are normally two methods. Number one is Raoult's method, and number two is integration method, or by integration we can find out the moment of inertia of a section. And let's remember one thing: the Raoult's rule is used for finding the moment of inertia of a plane area or a body of uniform thickness. If the plane area or the plane body has uniform thickness only, then we can calculate the moment of inertia by Raoult's method. If the thickness is ununiform or the thickness is variable in different part or in different section, we can't use Raoult's rule. Then only we can use integration method, right? So have a look how Raoult's method or Raoult's rule is coming. So this is moment of inertia by Raoult's rule. So what Raoult's rule is say? The Raoult's rule states that if a body is symmetrical, if a body is symmetrical about three mutually perpendicular axes. Our three mutually perpendicular axis is what? Our x-axis, our y-axis, and our z-z axis. So if a body is symmetrical about three mutually perpendicular axes, then the moment of inertia at any one axis passing through the center of the gravity is given by I is equal to A into S divided by 3. I is equal to A into S divided by 4, and I is equal to A into S divided by 5. Now you can see there are three different formula. So for which cases which formula should be applied? The first one is for square or rectangular lamina or section. So this formula is A into S divided by 3 is for a square or rectangular lamina. Now what is A? A is nothing but area of the plane area. And we can also say A or M, right? Or M. What is M? M is the mass of the body. We can calculate it as area, and we can calculate also by the mass of the body, or M, right? So and what is S? S is the sum of the square of the two semi-axis, other than the your calculated axis about which the moment of inertia is required to be find out. And this formula, the second one, is applicable for circular or elliptical lamina. And the last one, that is A or M into S divided by 5, is only for spherical body. You can say what? For a football, like a football, for spherical body. So these three different types of formula are used for three different types of section or three different types of lamina. First one, A into S divided by 3 for the square or rectangular, A into S by 4 is for circular or elliptical lamina, and the last one, A into S by 5, is for spherical body. Now remember one thing, this method has only academic importance as this is rarely used in the field of science and technology these days. What is the reason? The reason is for the same, is that this is equally convenient to use this method of integration for the moment of inertia of a body. Now move on to by the integration. By integration, this is very much similar to the moment of inertia that I calculated earlier, to divide it into various parts, that is small parts, A1, A2, A3, and calculate the corresponding distance of the elements from the line about which moment of inertia is required to be find out by R1, R2, R3, etc. and represent as area into distance square, that is perpendicular distance square, and summation is by integrating these parts we can find out the moment of inertia. Okay, so this moment of inertia can be determined by two parts, that is Iyy and Ixx. Okay, so that's all for today's class. Now in the next class we will calculate or we will determine how moment of inertia of a rectangular section and how moment of inertia of a hollow rectangular section, a circular section and a triangular section can be find out. Okay, so thank you.